Okay, so let's take a look now at some examples of the DeGroote learning and the influence vector in practice. And first we can start by just some simple situations where we see how people's position in a network translates into the influence. And one thing that's sort of interesting is that people who put huge weight on themselves, high weight on themselves, are going to end up maintaining beliefs while other people are changing over time. And so groups that are highly introspective and get listened to by other groups are also going to end up having their weight be very high in a society. So one thing that's sort of interesting about this model, and perhaps a little strange, is that groups that don't listen much to the outside, but end up being listened to a lot by the outside, end up having a large influence. So it's not only listening a lot to yourself, but also then having people listen to you. That combination can give somebody a very high influence because they don't update their beliefs much, and they end up eventually impacting others' beliefs. So when we look at another example of influence, suppose that actually what people did was equally weight their connections. And let's also suppose that that we think of these as friendships, so they're mutual. So Tij is greater than 0 if and only if Tji is equal to 0. So if I listen to you, you listen to me. So we have conversations, and I put equal weight on all my connections. So if you think then of a situation where Di is i's out degree, then Tij is going to be 1 over Di for each I and j. So everybody that I'm talking to, I put equal weight on. So however many friends I have, I give one, if I have 10 friends, I give 1/10 weight to each one of them. Okay, so let's think of that. That's a very simple version of this model. So if we let D be the overall total sum of out degrees in this model, where everybody's weighting their friends equally, then the claim is going to be that a person's influence is just going to be proportional to their degree. So this gives a foundation for degree centrality. In a world where you had conversations with people and you weighted everybody that you talked to equally, then your influence would be related proportional to your degree. And recall that S is a left-hand side unit eigenvector, so you need it to satisfy this equation. And so what you need to verify is that Si is then going to be equal to this sum over j's of Tji times Sj. Right? And so let's check that this actually works. So we've got this claim that this is the eventual limit, and we want to verify that this equation holds. So if we plug in for Si, try and check that we're going to get Di out over D. Well, what's this sum? This sum is the sum over all the people that I listens to. And because the listening is reciprocal, right? So Tji is greater than 0 if and only if Tij is greater than 0. So we're going to sum this over how many people I listens to, 1 over Dj, and we want to verify that if we stick in the s's for this, we'll get back the right answer. So we've got Dj over D. Well, these two things are going to cancel, the two Djs. And then we've got a sum which is proportional to the number of individuals that I is listening to. That's directly, so we've got 1 over D summed that many times, that's going to be Di over D. So indeed, check, we've got back the solution. So in a situation where you put equal weight on all your friends and listening is reciprocal, you get back degree centrality. So in that situation, eigenvector centrality and degree centrality actually coincide. Okay, so let's have a look at an example now, and this is a paper by David Krakauer where he looked at an advice network in a company, a paper from 1987, and this is one where we've got a few enough nodes and we've got information so we can actually calculate out what the S is. And in particular, this is a picture of the network. Now it's a directed network, so certain people could actually listen to others without them listening back. So this will be a directed network, not necessarily back and forth. And there are some individuals who actually aren't connected. So some individuals are not getting listened to at all, and their influence is going to turn out to be 0 in this situation. So it's not a strongly connected network. Nonetheless, the S is still going to work as the right answer to this. So if you go through and you figure out what the S is, so if you solve for the S of this, there are some individuals, for instance, 6 who didn't get listened to, and 13 and so forth, that end up with 16 and 17. So some people would end up with no influence. Nobody listens to them. It comes to them for advice. But basically, we end up with the advice levels varying from 0 up to, let's see, we've got a 0.2 here. So we end up with different levels of influence. And what the other columns in this table represent is sort of, these are levels of the individuals in a hierarchy in this company. So level 1, this is the CEO, the head of the company. Level 2, we've got people at the second highest management level. Then level 3 is the third highest level. And what we see is actually there are some people who are more influential in terms of this network than the individual at the top. Actually, one of the people at level 2 has a higher influence vector than the person at the top. And we can begin to look at different people. Different people at level 3 have different levels of influence. And you can look at that by the different department, their age, their tenure, and so forth. And this information is going to be complementary to some of those things. It doesn't just necessarily correlate with how old they are or how long they've been in the company or which department they're in. These numbers are telling you something different about the relative influence that these individuals have. So what that does is it just shows one example of where you can begin to take this DeGroot model. It gives just a foundation for looking at this particular left-hand side unit eigenvector as a measure of influence. And if you ran the DeGroot process on this particular network and had people updating over time in their beliefs, that would tell you what the beliefs would eventually converge to. And this was done under the assumption that, so we don't know exactly what these weights are, that people put equal weights on each one of their friends that they said. So person 17, for instance, has 5 out arrows, so they put 1/5 weight on each one of these. So that gives us one example of the influence of how coming out here. And again, we see the relation of this to the eigenvector centrality, and that's coming back from this relation of matrices to powers, which was underlying eigenvector centrality. Okay, so that's one of the applications of this. That gives us some perspective on this DeGroot model. We'll wrap up some of our discussion of learning next, and then after that we'll start talking more about games on networks.